Let's talk about dApps. So what is a dApp? A dApp is a decentralized application. And there are kind of varying definitions really for what that means, but I'm going to say that basically a dApp is any application that, has a fundamental dependency upon the blockchain. And, some people might disagree with me with that. They might say, no, it has to have smart contracts, or no, it has to be smart contracts only, or no, it has to be only smart contracts and a browser, application, like a web application or a front end of some kind. There's lots of different definitions, but I'm going to, loosely say that a dApp is any application has a fundamental dependency upon the blockchain and a actually just centralized component that's based upon the blockchain. It actually uses the blockchain to achieve decentralization. You don't necessarily have to have smart contracts to do that. But anyways, I digress. So there are lots of different ways we can talk about, what that looks like, and I'll demonstrate that in a moment. But before we get into all the technical details, let's just look at a dApp. So this is, CryptoKitties, one of the most popular dApps out there, most famous dApps out there at least, that, became infamous for clogging up the Ethereum network at the end of 2017, I believe. So what can you do with CryptoKitties? Well, CryptoKitties is basically a website that is powered by smart contracts, also has a web server, which we'll talk about in a moment. But basically, it uses this technology called non-fungible tokens, which allows you to purchase unique cats on the blockchain with smart contracts. So I just want to kind of give you a high-level overview of what it is so you can see how to use a dApp. So I'm logged into CryptoKitties, and I can purchase a kitty with smart contracts if I have MetaMask enabled in my browser. So I'll just go ahead and purchase one. Like, I'll just pick one of these cats. I'll click on it, and we should see it come up, and I can buy it. So they're technically on auction. It's a Dutch auction where you have a countdown timer like this. But I'm just going to click it, buy now. And MetaMask should pop up, but I'm just going to open it anyway. And it'll say, do I want to confirm this transaction? So here's the estimated gas fee. I'm actually going to edit it. I'm going to make this faster. So I'll click save, and it'll take about 30 seconds for my kitty purchase to happen. And I'll click confirm. All right, so it's on his way. And we can see view transaction status. Go Etherscan and wait for this transaction to be mined. All right, you can see it's pending. So I'll come back in about 30 seconds. Look at this. So in the meantime, while this is happening, let's just kind of get an overview, right? So this is a dApp. It's a website that is attached to smart contracts. It also has a web server backend that probably has a database that's capturing my email address and Ethereum address. So it's not completely decentralized. It's a hybrid application, which I'll kind of talk about in a minute when we talk about the different technical kind of infrastructure for dApps, right? But this at least is reliant upon smart contracts. It's got a website, it's got a back end, and this is how you would use it. You need MetaMask installed, you need to be able to purchase a cat, and you can see the transaction going through. And this is pretty common UX for dApps right now. Whenever you create a transaction on the blockchain, it takes time for it to be mined, and this is really good user experience to say, hey, something's happening in the background, wait on it. You can do something in the meantime, and here's your transaction status. You can go look at it yourself on Etherscan. And this is a really good way to basically ensure that your dApp is, trustless, like it's working, and people can transparently see what's going on the blockchain whenever they made a purchase. They can wait for their transaction to finish. So mine's finished, and we can see all the information. Here's the transaction hash. Here's the block that was included in. I bought a kitty. It was transferred to me for this much Ether. We can see the transaction here in MetaMask, right? We can see it pop up. So it'll cost me a little bit of Ether, but now I have a new kitty, and I can put him in my wallet. All right, so that's kind of basically how you interact with a dApp. And there's lots of dApps we could talk about. I just want to talk about CryptoKitties because it's one of the most famous dApps, and it's pretty straightforward to use. So let's talk about the technical overview of how dApps work. Okay, so if you look at a traditional, web application, just a website, right? Let's say a social network where you have, a user name and a password, and you can get onto the website and look at friends and tweet and share pictures and all that kind of stuff. that website in high level works like this. You get a browser and you connect to a website that's going to serve all the HTML and CSS. That's going to be your front end. This might be like a JavaScript application. Let's just say it's written in React for example purposes. So you're going to have like a React app here that you hit directly with your browser. That's going to be on maybe one server. Let's just say another server. You have a backend, right? This is going to be a server that stores like all your user data and all your business logic for your app. And there might be another server that stores your database, right? So there's potentially 3 servers involved here, maybe more. And in a production application, there's going to be lots of servers. Like you're going to have load balancers and all kinds of crazy stuff. But, this is how it works. You basically hit a browser, you hit a front-end website, and then you hit a back-end. So, and that's going to, that's how that's going to work. So for a dApp, there are a couple different patterns, but the simplest one and maybe the most pure one that a lot of people will kind of stick with, which I'll show you right now, is this pattern. So you'll have a website, from my pencil. You have a website that will talk directly to a server that contains your front end. And let's say this is written in React or something like that, right? And this is going to talk directly to the blockchain. And the blockchain will have, smart contracts, or maybe it'll just create transactions, whatever it is. There'll be some sort of decentralized component that will utilize the blockchain and, whatever resources are available. So the smart contracts are just creating transactions or reading data from the blockchain, whatever. This will be maybe, a pure dApp in essence. And you can make this more decentralized, right? You can take this React app and compile it down and put it on IPFS, right? Which would be a distributed system. Or you could, offer your HTML and CSS code as open source for people to download and run themselves. If they didn't completely trust your website, they could, see everything and run it themselves if they wanted to. That'd be another way to be completely decentralized, right? So from a lot of production use cases, though, many people are going to have this hybrid model where they're essentially going to, let's see here, take their browser and point it to a server that's going to serve all the HTML, CSS, and JavaScript, the front end basically. And that is going to potentially talk to a few different components, right? It might talk to a backend that stores some user information or maybe some other business logic for the application. And it might talk directly to the blockchain to interact with smart contracts, right? And your backend actually might talk to the blockchain, like to index some data or, create machine run transactions on the blockchain or maybe talk to a smart contract or just pull data off of it or whatever, right? So there's a hybrid approach where you may not want to do everything on the blockchain. You want to use a web server for some things. And there's going to be a sliding scale here on how much users are going to trust your application. If you're storing user data, pure blockchain purists, users who fall in that category may not trust your site as much. But if you're only storing really benign user data on the back end, or maybe not user data, but just benign data of any kind, then people may not care. So an example might be like a cryptocurrency exchange that's powered by smart contracts that uses, web server for its order book, right? And, maybe the smart contracts manage the exchange part itself. So that'd be a case where the only thing you're storing is information that people are okay with you storing on a web server. Okay, so that's an alternative in a way that you could do a hybridized model of a dApp that uses a web server for, performance basically, and then uses the blockchain for stuff you need to use the blockchain for. All right, so that's an overview of how dApps work. We're going to dive more in depth into some of this pieces of communication when we look at our introduction to smart contracts and also our introduction to Web3 and how to connect your applications to the blockchain. So check out those next videos.